Good morning. Today is Friday, January 5th, and we are going to go through a second day of chain rule. Now, hopefully you all got online and you looked at your key for your homework. That was numbers 1 through 14. If you had any questions, please feel free to ask your classmates. You can come up to the board and work it out and talk it out. But please feel free to work together and show each other maybe some of those trig ones at the end, and we'll go from there. Today is going to be day 2 on the chain rule. So we're basically going to be practicing some more chain rules. I'm going to throw a little bit of a wrinkle in. Everything we've been doing has been in terms of x. We might throw in another variable today. So let's see how this goes. Day 2 on chain rule. First thing I have is an application for you. Go ahead and read it. Okay, first thing I need is an equation. If I'm going to do any kind of derivative or any kind of chain rule, I need an equation. Well, I've got a balloon and its volume. We're going to say the balloon is a sphere. And the formula for volume of a sphere is, so that's what we're going to use. It says, suppose the radius r of a balloon varies with respect to the time according to the equation. Now it's telling me what r is. So I need to go ahead and put r into my equation like they tell me here. Looks like that, because it says it varies with respect to time, and time is t, so I got to have t in there. All right, it says find the rate of change. Rate of change, you know, means limit, means slope, means derivative. So I need to find the derivative of this thing. Well, if I take a look at it, this thing to me doesn't even look like a chain. It looks like a product rule. I've got this, and I've got this. So I'm going to go ahead and derive this by using, oh my gosh, I'm so sorry. This is a chain because I forgot part of my formula. This should have a third power on it. Now it most certainly is a chain. So my big function is going to be that, which when I derive it, gives me that. My small function is going to be what's in the parentheses. And when I derive it, I just get 2. All right, so let's find the derivative of volume with respect to time. Please notice the notation that I use there. Derivative of volume with respect to time, dv over dt. All right, so derivative of the big function with the little function inside times the derivative of the little function. Put it all together, and this will be my final answer. Okay, let's go ahead and try some more chain rule. Big function. Let's see here, 7/4 minus 1 is that. Small function. Looks like that. So if I'm going to find this derivative, big derivative with the small function times small derivative. So if I multiply that, that's 42 over 4. 42 over 4 reduces to 21 over 2. And don't forget to put your x in there. And that will be my final derivative. Okay. Let's do one with a natural log in it. Now, I don't think that we've done the derivative of natural log yet, so I went ahead and put that up there. You can go ahead and put that on your sheet. And the big function here and the little function looks like that. So let's find the derivative. So the derivative of y with respect to x, I need to get you used to that notation here. Big derivative with the little function times the little derivative, which looks like that. Now, these are just being multiplied, so I can go ahead and do this. I probably can reduce this a little bit. So it will look like that as my final answer. All right. I am going to skip this slide for a minute, and I'm going to come back to it because now I want to talk about the composition of three functions. Okay, if I'm going to do the composition of three functions, I now have a small function, I have a medium function, and I have a large function or a big function. So now we're going to have three pieces. And hopefully you can kind of see why we started to call this a chain rule, because it all gets linked together. So if I take a look at this example, I've got to figure out the big function, the medium function, and the small function. Well, please notice that the third power is on the cosine. So that's an x to the third for my big function. Now, since it's on the cosine will be my medium function. And then the small function is the angle. All right, so let's do the derivative of the big function with the medium function. Okay, now, the way the chain works is you have to put in all of the smaller functions. So, if I'm going to be smart about this, I need to make sure my functions are correct. So, that would be your medium function, and then this would be your small function. Okay? I think it's actually easier to go ahead and just make this a regular x here. But you have to be in the understanding that all of the smaller functions have to go in the larger functions. So let me go back here. I took the derivative of the big function, which looks like this. Now I have to put in the smaller two functions. So it would look like that. Okay, now I'm going to multiply by the derivative of the medium function, but I have to put the small function in there. And then I have to multiply by the derivative of the small function. So it looks something like this. When you combine everything together, it looks like that. I need you to realize that there's a little bit of a trickle-down effect here. Okay, when we go from the top to the bottom, you have to make sure you're putting everything in. This has to go in there, then this goes in there. Then this goes in there. They are all linked together, and hopefully as we do a couple more of these, you will see that. Okay, take a look at this one. Big function. Medium function. Whoops, these aren't x's, are they? They're y's. Let's make sure we change these to y's. Medium function. And small function. Okay, so here we go. We have the big derivative with the medium and small functions. So the big derivative with the medium and small functions. So basically, I put this into here, and then I put this into there. Now I need to multiply that by the medium function with the small function. So this time I took this and put it in there. And then I got to multiply by the small derivative. So all together here. it should look something like that. Biggest mistake people forget is not multiplying by that small derivative at the end. All right, so now I actually have 4 functions. The biggest function is a sine function. The medium function is the cosine function. I'm sorry, the large function is a cosine function. The medium function is x to the 5th. And the very smallest function is tangent of x. Looks like that. So let's put all of those chains together. Big derivative. And I need to put all of these into that big derivative. So this will be the cosine of the cosine to the 5th of tangent x. Now I have to take the large derivative and I have to put both of these into there. So this will be negative sine to the 5th of tangent x. Now I need to take this and put it into there. And then I need to multiply by the little derivative. So, is there anything that I can combine? I can basically just pull this negative 5 out front, and then everything else is going to stay the same. I have some people that ask me, can I take this with this and make it tangent to the 6th? And that answer is no, because this tangent and this tangent are angles. Okay, they are in where the angles are. Okay, let's go ahead and go back to this slide. It says express each derivative with respect to x. Now, the first thing I need you to notice is in a and b, there are no x's. So I'm asking you to do the derivative of this with respect to a variable that's not there. Okay, you're like, well, how are we going to do that? Well, basically, we're going to derive it like normal, and then we are going to put some notation on the end that says, yeah, we know there's none of the variable there that we want, so we're just going to put this notation on the end. So I need to take the derivative of y to the 3rd. Well, the derivative of y to the 3rd is that. But that's with respect to y. I want to be with respect to x. Well, what's the notation for the derivative of y with respect to x? The notation is that. So I'm just going to put that on the end, signifying that, yes, I was supposed to take this with respect to x, but there wasn't any x's in there. So this notation lets my reader know that. Okay, let's do the next one. The derivative of sine y is cosine y, but that is not derived with respect to the correct variable. So we're going to put our dy dx on the end of it. Next one gets a little bit more complicated because this is a product rule. Okay, there's my 2 pieces. So the product rule says take the derivative of the first times the second. No problem there because the derivative that I took was of the 2x to the 3rd, and that has x's in it. So I can leave that like normal. Now I have to take the derivative of the second. Well, the derivative of the second is this, but I'm not deriving x's, so I need to put my notation on there that says I need to derive this with respect to x. But remember, the product rule says you take the derivative of the second times the first. So we can't forget to put that in there. And now we're just going to write this a little bit nicer. Alphabetical order. And then the dy dx is going to go on the end. This is something that we're going to use a lot at the end of the school year. So I just wanted to give you a little bit of a taste of it. Okay, so those are our notes for today. Your homework that goes with this is that. And again, I am going to go ahead and work out a couple of these just to give you some more instruction, some more practice. Okay, so let's take a look at number 23. I need a big function. I need a medium function. And I need the small function. Now notice I inadvertently made these x's. I hope you don't mind. Most of you like to work with x's anyways. Okay, here we go. Big derivative with both the small and medium functions inside of it. Big derivative with the small function, with the medium function and the small function, times the medium derivative with the small function times the small derivative. So if I put that all together, 2 times 18 is 36. Pull that negative out. I also have the x to the 5th. And then I have my trig portion of this. And that is going to be my answer. Number 29. Let's take a look here. My big function. Big function is going to be tangent of x. Medium function is going to be e to the x. And the small function is going to be that 3. Again, I inadvertently have turned the t into x. Okay, so I need the big derivative with both the medium and small functions inside. Then I need the medium derivative with the small function, and then I need the small derivative. So final answer will look like that. Again, I remind you, the first thing I'm doing is putting this into that, and then taking what I get and taking this and put it into that. That is your first chain. That is this portion right here. Then I'm taking this and putting it in here. That's this portion. And then we're multiplying by the little derivative, which is that right there. Let's look at number 40. Only 2 parts here. Big function, little function. All right, big derivative with the little function times the little derivative. And I can multiply that -6 through if you want. If you don't want to, that's fine as well. I think I will. Your book has this written a little bit differently. They actually move the negative powers to the bottom, but you don't have to. You can leave it just like this. All right, last one here. Let's do 46. Big function. Okay. Derivative of cosecant is something that you should have. Okay. That is cosecant, cotangent. My medium function is going to be that. I'm sorry, my medium function is going to be x squared. And then my small function is going to be that. All right. Now there are 2 x's Here, folks, I have to take this and put it in there, and then I have to take this and I have to put it in both of those X spots. Looks like that. Then I need to multiply the medium derivative with the small function inside. And then I need to multiply by that small derivative. So I can distribute the 2 and the -3. So really I'm distributing a -6 here. So I have -6 plus 18x and that is going to be my answer. Now, the book doesn't have you distributing the -6. Okay, I did. Again, there's multiple ways to write this. Okay, so hopefully you tried those on your own before you listen to my explanation. And then obviously you have a couple more to do. So remember, your key is posted for your bookwork. And then the rest of next week, you're going to be doing worksheets that will practice doing the chain rule.